Yeah? Okay, so my presentation is on the dot product and on the angle between vectors. The dot product is an equation, which is the vectors, which is you write them as A, B, the two numbers, and you do the first number of the first one and the first number of the second one multiplied, and then the last two numbers multiplied, and you add them together. The dot product is mainly used as part of the equation to find the angle between the vectors. That's like what the main point of it is. So for example, in a 2D vector, for that you would do u times v, and you would get 6 times 5 plus 15 times 3, and then you would just simplify it out and get 30 plus 45, which is 75. And then for the 3D, you would do the same exact thing. You would, well, here, does anyone want to try the 3D one? Come on up. It's the same thing. You just have 3 numbers instead.
I'll try.
Any takers? Come on up.
Yeah. Look at American to get it wrong. Thanks. That's how it's like.
The first numbers and then the second numbers. Negative 78.
There we go. Math.
Yes. So that's pretty much how you would do 2D and 3D vectors. I think one of the most complicated questions that they can ask with the dot product is then you would have to like first start with like multiplying vectors with numbers, which would be the scalar product, which is when they ask 3 times u and then times negative 5 times v, which is you would multiply 3 times u first. So you would do like 3 times 6, which is 18, negative 3, and 0. And that's what your new u. And then the new v would be 10, negative 40, and negative 20. And then once again, you multiply it out, and you would get 180 plus 120 plus 0, which is 300. So that is like, that's the dot product. Like, that's as complicated as it can get. And then, how do I scroll down? Okay, so then it's the angle between vectors, which is a little more complicated. So you would have like 2 vectors. And to find theta here, you would use this equation. Cosine of theta is equal to vector u times vector v, which is the dot product, which is why we have to be able to calculate it, and then times the 2 magnitudes. The magnitude is also the length of the vectors, and the equation for magnitude is the square root of the 2 numbers in it. So if your vector was 2, 5, the magnitude would be 2 squared plus 5 squared. And it actually makes a lot of sense, because if you were to graph the vector and you were to go 2 to the right and then 5 up, then for the quadratic formula, you would do the square root of 2 squared plus 5 squared. So that's how you would get the magnitude. And we derive this formula out of the law of cosine, which is in a simple triangle that says A, B, and C. It's kind of small. The law of cosine, which is c squared is equal to a squared plus b squared minus 2ab cosine theta. So in any simple triangle, instead of putting a, b, and c, you could put vector a, vector b, and then the one in between is a minus b. That's how you would find this one. And then this is the same simple triangle, except it's talking about the lengths, which is also the magnitude. So these are similar triangles, which shows that theta is the same in both. And then you just plug it into the equation. So c squared, which would be this one, or this one, either one, squared is equal to a squared, and then we just plugged it all into the formula. I left the right or to you guys left. Okay, I left this side by itself, like I just like put it aside for now, and I like derived this one first. So since it's squared, you just know that it's a minus b times a minus b. And then I used FOIL, and I FOILed it all out. And then a times a is a squared minus 2 times, and here's the a and b, which would make it twice, plus the vector b squared. And then that's when I put it equal to what we had in the beginning. And you cross off everything, and you end up with the dot product, which is vector a times vector b, which is equal to the 2 magnitudes times cosine of theta. And if you divide it by the 2 magnitudes, you get the equation that was up there too. Like you get the equation for the angles between the vectors. And so I guess so this is what they would give you. They would just give you the 2 vectors, u and v. So first you would find the dot product, so first you would find the dot product, which is u times v, and it's and then you should get 16. And then you find the magnitude of each one. So the magnitude of u would be the square root of all of the numbers squared and then added together. So square root of 9 plus 16, which is 5. And then you would do the magnitude of v, and you should get 9. Right? So then you have the 3 parts to the equation. So then you just plug it in and you get the cosine of theta is equal to the dot product, which we got as 16, over the magnitude of u, which is 5, times the magnitude of v, which is 9. So to find theta, you do the anti-cosine of 16 over 45, which should give you 69.17 degrees. It's pretty simple. I think the most important thing in this calculation especially is, well, I think one of the easiest mistakes people can make is that we're talking about angles and in degrees. So most people in the calculator are in radians. So everyone gets the answer wrong, and they would get 1 point something instead of changing it to degrees and getting your equation, if you're getting your thing right. And that's pretty simple. The only other thing, oh, it cut off. But anyways, the only other thing is that, so those are 2 angles. If you were to have addition vectors, and it would look something like that, the way to find the angle between them is if this were vector v and this were vector u, what you would do is you would do negative u, which would be that angle, and you would get the same thing. So you would just change u to negative, and then you could find the angle between the vectors. And that's it. That's all I got.